Hello viewers, welcome to my channel. I am Hasham Ali Khan. So now I am going to start a new topic in the subject statistics for management. The topic is correlation analysis. Already three topics I have covered in this subject. Measure of central tendency, measure of dispersion and measure of skewness. So if you have watched all those videos, definitely you will get a good command on the basics of statistics for management. If you have not watched those videos, I suggest you first you go to the playlist of my channel. Select the subject statistics for management. Watch the videos regarding how to calculate the arithmetic mean, median, mode, then measure of dispersion and measure of skewness. Because those are the fundamental basics of statistics. And only after learning that, after understanding that, you can easily understand correlation analysis. So in this video, I'm going to explain you about the meaning of correlation, why we calculate correlation, what are the methods of calculating correlation. So without watching this video, don't rush to watch the problems. Problems are based on the theory. And in examination, not only problems, but many a times, theory will be asked. So you must have the conceptual clarity regarding the topic. Then only you should go for problems. So watch this video till the end. Don't skip in between. So before explaining this concept of correlation, take a screenshot of the points which I have written on the board. Then I'll explain each and every point about correlation analysis. So now I'm going to start the topic of correlation analysis. Correlation is a statistical technique which is applied to analyze the behavior of two or more variables. In other words, it's a statistical technique which study the relationship between two variables. In our lives, we can see many times a relationship exists between different variables. So we want to study what is the nature of relationship between different variables. So it is a statistical technique. This correlation is a statistical technique which is applied to find the relationship between two variables. Example, we can say advertisement and sales. Normally in a business, when advertisement is given, the sales will increase. Higher the advertisement, more would be the sales. Similarly, the price of petrol, nowadays the price of petrol are shooting up. When the price of petrol increases, the demand for cars may decrease. Similarly, when the income of the people increases, the investments will also increase. Like this, the income and investment are related. If there is a change in income, correspondingly there is a change in the investment. If there is a change in advertisement, it leads to change in sales. If there is a good rainfall, there is possibility of good production, agricultural production. Like this, so many cases are there where we have some relationship between variables. So this statistical technique will be applied to study, to analyze the behavior of two variables. If there is a change in one variable, correspondingly there will be a change in the other variable if the two variables are related. So here I have given correlation means the relationship between two variables where with the changes in the value of one variable, the values of other variable will also change. If there is a change in one variable, correspondingly there is a change in the value of the other variable. So this correlation will explain the relationship between variables. In other words, we can say correlation is a statistical technique which is applied to find the nature and degree of relationship between two variables. So two concepts you remember, nature and relationship, degree. So it is a statistical technique which is applied to study the nature of relationship. Nature means whether the relationship is a direct relationship or inverse relationship. Direct relationship means if there is increase in X, correspondingly there is an increase in Y. When there is increase in advertisement expenditure, there is increase in sales. It is called direct relationship. Whereas some other variables, we have inverse relationship. If there is increase in the value of X, correspondingly there is a decrease in the value of Y. This is called inverse relationship. So this correlation will explain you what is the nature of the relationship, whether it is a positive relationship or negative relationship, direct relationship or inverse relationship. Similar degree, whether the relationship is of high degree or medium degree or low degree relationship. So this statistical technique will be applied to study what is the nature of relationship and what is the degree of relationship between two variables. This is the explanation regarding the meaning of the term regression. Now, importance or significance of correlation analysis. Why we study this correlation analysis? What is the importance or significance? First point, understand the direction of change in one variable given a change in another variable. Every business organization wants to find out what is the direction of change. If there is a change in X, what is the corresponding change in Y? What is the direction, whether it is positive or negative? So to find out the direction of change in the variables, we need to study correlation analysis. Next, measures the extent of relationship between the two or more variables. Extent means degree. Whether the relationship is a strong relationship or a weak relationship. To find out the relationship between variables, we study correlation. Next one, correlation helps in decision making. A number of decisions has to be taken by a businessman. So this correlation analysis will be helpful to the management, to the managers to take the decisions. Next one, correlation enables us to understand the interdependence of the variable. See, I told you, many variables are there which have some relationship. So a business manager has to study. So what is the interdependence between different variables? Example, the management wants to find out if in order to attain so much of sales, how much advertisement we have to spend. What is the relationship between advertisement and sales? Like that. Next one, other statistical measures such as regression coefficient are calculated with the help of correlation coefficient. This correlation analysis study is not confined only to find out the relationship, but this correlation coefficient will be applied in other statistical analysis like regression. After completing this correlation, I am going to start up regression. In calculating regression coefficient, we require correlation. We take the help of correlation analysis. So this shows the importance of correlation analysis. Now, types of correlation. Correlation can be of different types. First, positive or negative correlation. Positive or negative. Positive means when both the variable moves in the same direction. When there is an increase in X, correspondingly increase in Y. It is called positive correlation. It is called positive. Best example of positive correlation is advertisement and sales. Another example is income of the people and investment. We can make relationship. Higher the income, more investment. Higher the advertisement, more is the sales. It is called positive. Negative correlation. One variable increases, the other variable decreases. When the price of X increases, the demand for Y will decrease. Like that, negative relationship. Example, best example for negative correlation is petrol, price of petrol and demand for cars. When the price of petrol increases, the demand for vehicles will decrease. The demand for vehicle will decrease. So one variable increasing, the other variable decreasing. That is the example of negative correlation. So next one, linear or non-linear correlation. Linear correlation means the percentage change in one variable is exactly equal to the percentage change in the other variable. Example, the advertisement increased by 10%. Advertisement expenditure increased by 10%. correspondingly sales also increased by 10%, exactly 10%. So here 10% increase in advertisement leads to 10% increase in sales. If this happens, it is called linear correlation. But normally we seldom come across linear correlation. Many times we come across non-linear correlation. That means the percentage of the variable change will be different. Example, if we increase advertisement by 10%, the sales increased by 25%. Only 10% we increase advertisement, but our sales have increased by 25%. In this case, the correlation is called non-linear correlation. Simple and multiple correlation. Simple correlation means only the correlation between two variables. The sales depends on advertisement. The sales depends on advertisement. So we can say there is simple correlation because only two variables we are seeing, that sales are completely dependent on advertisement. Multiple correlation means when one variable is dependent on a number of other variables. Example, sale does not depend only on advertisement. Sales depend on the price of the product. Sales depend on the income of the product. Sales depend on the taste and fashions of the people. That means the sales are affected not only by advertisement, by n number of factors are there. So if we study the relationship between among all the factors, it is called multiple correlation. If we study the effect of only two variables, it is called simple correlation. Partial and total correlation. Partial means out of so many variables, we are taking only few factors. That means the sales are dependent on advertisement, price, income, taste and fashion, so many items, but we are taking only two. Only two. Sales are dependent on price of the product and advertisement, leaving the other variables, ignoring the other variables. It is called partial correlation. If we take all the variables which affect the sales, it is called total correlation. These questions will be asked in examination theory question regarding what is linear, non-linear correlation, what is positive, negative correlation, what is partial, total correlation, like that. So whatever I have explained, keep it in mind. You can definitely score good in examination. Now, methods of studying correlation. So far, I have explained you about meaning of the term correlation. Now, what are the methods of calculating correlation? Many methods are there, but for our purpose, I have taken only three methods. The first method is scatter diagram method. Second, Pearson's coefficient of correlation. Third one, coefficient of correlation by rank differences. Apart from that, concurrent deviation method is there, graphical method are there. Just having note, only three I am going to explain. Scatter diagram method. Scatter diagram method is a diagrammatic method or graphical method where on x-axis we take one variable, on y-axis we take another variable. The two variables are taken on two axes of the graph paper and we plot all the points on the graph paper. Example, when we incur 10 lakh rupees, the sales are, let it be 80 lakh. When we incur 15 lakh rupees on advertisement, the sales are 1 crore 20 lakh. Like that, we have pairs. We have pairs of values. One value advertisement value, the other value sales value. We have plotted all these points on the graph paper. Now closely, if we watch the points on the graph paper, we can say whether relationship is existing or not. If the points are showing an upward trend, that means there is a positive relationship between the two variables. If all the points are showing a downward trend, it shows there is a negative relationship between the two variables. If all the points are scattered on the graph paper, neither showing an upward trend nor showing a downward trend, we can say there is no correlation at all. So this is scatter diagram method. Next is Pearson's coefficient of correlation. The most commonly used method to calculate the coefficient of correlation is Pearson. This is a statistical method which is very widely, popularly used to find out the coefficient of correlation. And third one is coefficient of correlation by rank differences. So I'll explain that rank difference after completing Carl Pearson. First we'll discuss about Carl Pearson. So Carl Pearson's coefficient of correlation. In the next video I'm going to start the problems. Most of the problems are on Carl Pearson only. So Carl Pearson's coefficient of correlation is arrived at with the help of statistical formula. So Carl Pearson, he has propounded this method, how to calculate the coefficient of correlation. And his formula is based on arithmetic mean. It's a statistical formula that takes into account the mean. Mean means arithmetic mean, standard deviation, the number of observations and the covariance between them. So Carl Pearson has given a statistical formula to calculate correlation coefficient. In this formula, he has used the arithmetic mean, standard deviation, number of observations and the covariance between the values. By using all these four items, he has derived a formula. The value of correlation coefficient range between -1 to +1. So Carl Pearson says the value of correlation coefficient will range from -1 to +1. -1 to 0, 0 to +1. The coefficient will never exceed +1, nor the coefficient will be below -1. Neither below -1 nor above +1. It will range between -1 to +1. What -1 denotes? There is a perfectly negative correlation. There is perfect negative correlation, then the coefficient will be -1. Example, if the price of petrol increased by 10%, the demand for cars decreased by 10%. The price of petrol increased by 10%, demand for car decreased by 10%, it is called -1. The correlation coefficient will be -1, perfectly negative. And perfectly positive, +1. When you will get correlation coefficient +1, if the percentage change in one variable is exactly equal to the percentage change in another one. Example, advertisement increased by 10%. When we increase the advertisement expenditure by 10%, exactly 10% increase in sales. It is called perfectly positive correlation. But these two extremes, -1 and +1, will seldom occur in our practice. It will range between -1 to +1. If you get correlation coefficient 0, it means there is no relationship between the two variables. That is the explanation given by Carl Pearson. Now, properties of Carl Pearson's correlation coefficient. First property, it is based on arithmetic mean and standard deviation. Just now I told. Carl Pearson's formula is dependent on two items. The main two items are arithmetic mean and standard deviation. That's why I told you, before doing this chapter, you must be clear regarding how to calculate the arithmetic mean and standard deviation. Already I have uploaded the videos in the measure of dispersion and measure of central tendency. Next, it measures both direction of change and degree of change. So this correlation coefficient will explain you the direction of change. Direction means whether it is a positively correlated or negatively correlated. And degree of correlation, whether there is high degree of correlation or low degree of correlation. So both will be explained. Direction and degree will be explained by this coefficient of correlation. Third one, it is independent of change in scale or origin. In other words, if a constant amount is added or subtracted from all values of variable, the value of R does not change. The coefficient of correlation calculated by Carl Pearson is independent of change in origin and change in scale. Change in origin means if a constant value is added or if a constant value is subtracted from all the variables, the value of R will not change. The correlation coefficient, R is a symbol. This R is a symbol which is used to denote correlation coefficient. To denote correlation coefficient, we use R symbol. So the value of R will not change even if we add a constant value to all the variables or if we subtract a constant variable from all the variables, the value of r will not change. That is called independent of origin. And independent of scale, if a constant is multiplied to all the variables, or if a constant is divided to all the variables, the r value will remain same. That means whether a constant is added or subtracted, or whether a constant is multiplied or divided to all the variables of the data, then the value of r will not change. That is the property of Pearson's correlation coefficient. Next, computation of Pearson's correlation coefficient. Now I am coming to the formula. What are the formulas given by Pearson's to calculate the correlation coefficient? Here two methods are there. If the deviations are taken from actual mean and the deviations are taken from assumed mean. So first you have to calculate the mean value, arithmetic mean. If the arithmetic mean is in a whole number, not in fraction, it is in a whole number, then take the deviations from actual mean. Take the deviations from actual mean and apply this formula. R is equal to summation xy divided by summation x square into summation y square under root. Small x, remember, not capital X, small xy. So this formula, a small formula, summation xy divided by summation x square into summation y square under root. This formula will be applied when deviations are taken from actual mean. And small x is equal to capital X minus x bar. X bar means arithmetic mean. Similarly, y, small y is equal to capital Y minus y bar. This is x, this is y. So when this first method will be applied, if the mean is in whole number and we take the deviations from actual mean. Second, when the mean is in fraction. When you calculate arithmetic mean, the arithmetic mean is in fraction. In that case, take the assumed mean. Take all the deviations from assumed mean. So if you have taken the deviations from assumed mean, the formula for R is summation dx dy minus summation dx into summation dy by n whole divided by summation dx square minus summation dx whole square by n under root. Then again under root summation dy square minus summation dy whole square by n. So this formula will be applied when deviations are taken from assumed mean. When we take assumed mean, if the actual mean is in fraction. That's all. These two formulas you have to remember for calculating Pearson's coefficient of correlation. The next topic is probable error of the coefficient of correlation and its interpretation. There's a technique to check the significance of the value of R. We have applied this formula to calculate R value. R is the symbol for correlation coefficient. So we have calculated correlation coefficient R value. Now the question will arise, is this R value dependable? Is it significant or not? Is it reliable or not? To check the reliability of the value of R, we apply a test. That test is called probable error, PE, right? So the probable error of the coefficient of correlation helps in interpreting the value of R. The PE of correlation coefficient is obtained as follows. Interpreting the value of R, we use the technique PE. How to calculate probable error? 0.6745 into 1 minus R square by under root n. This is the formula to calculate PE. After calculating PE, you have to interpret. So how to give the interpretation? Here it is given. If the value of R is less than PE, R is not at all significant. That is, there is no evidence of correlation. After calculating the PE value, now you compare the PE value with R value. R is the coefficient, correlation coefficient. If the value of R is less than PE, there is no evidence of correlation. We cannot depend on the value of R. The R value is not dependable. When? If the R value is less than probable error. That is the first conclusion. Second, if the value of R is more than 6 times the PE, it is significant. If the PE is added, is significant. That means if the value of R is more than 6 times of probable error. More than 6 times of probable error. Then we can say the value of R is fully dependable. It is reliable. It is correct. We can depend on the value of R because the R value is more than 6 times of probable error. That is the interpretation. Now, if the probable error is added or subtracted from a coefficient of correlation, it would give two such limits within which we can reasonably expect the value of coefficient of correlation to vary. So after calculating probable error, we can add and deduct to the R value. So from R value deduct P, we'll get the lower limit. To R value we add the probable error, we'll get the upper limit. So we are getting two limits of R within which the correlation will lie. Within which the correlation will lie, lower limit and upper limit. How to calculate? First you calculate R value, then you calculate PE value, probable error. Subtract PE from R, you'll get the lower limit. Add PE to R, you'll get the upper limit. So actual R will lie between this lower limit and upper limit. That is the interpretation of R. So I have explained you the meaning of the term correlation. What is the significance or importance of calculating correlation? Then what are the different types of correlation? Then what are the methods of calculating correlation? The first method is only a scatter diagram method that is not reliable because only a bird's eye view we can be able to get by applying scatter diagram. Pearson is the most widely used method, where this is a statistical method in which the Pearson has used arithmetic mean, standard deviation, number of observation, covariance to calculate the correlation coefficient. The value of correlation will range between -1 to +1. It will never exceed +1. It will never be below -1, right? And the correlation coefficient is independent of change in scale and change in origin. I have explained the formula, and lastly I have explained probable error. So normally there are three methods of calculating the coefficient of correlation: scatter diagram method, Pearson's method, and Spearman's rank correlation method. So far we have discussed the scatter diagram method and Pearson method. Now I am going to explain you about the rank correlation coefficient, which was suggested by Spearman, Edward Spearman. So first you take a screenshot of these notes regarding rank correlation coefficient. Then I'll explain all the points how to calculate the correlation coefficient by rank method. Come on. Sometimes we come across where statistical series will consist of variables which are not capable of measurement. See here, every statistical data is not measurable. Some statistical data is there which can be felt but which cannot be measured quantitatively. So in those situations where the statistical variables are not capable of being measured in terms of specific units, in those cases we cannot apply Pearson's. Pearson's can be applied where the variables can be measured in terms of some units. So in situations where we cannot measure, we apply the rank correlation method. Example of those variables which are not measurable are honesty, beauty, efficiency, morality, the character. These are the items which we can feel. For example, we can see that a person is beautiful, a person is honest, a person is efficient, a person is having good character, a person is having good morals. But these things we can feel, but which we cannot be able to measure it. So in these situations, if you want to find out the correlation, there is a separate method propounded by Edward Spearman. That's why the name is given Spearman's rank correlation. So we will assign the rank to the variables. We will not take the variables, but we will take the ranks. So sometimes we come across where statistical series in which the variables are not capable of quantitative measurement but can be arranged in serial order. The items can be arranged in some serial order but we cannot quantitatively measure. This problem arises while dealing with qualitative characteristic. Qualitative characteristic, not quantitative characteristics, such as honesty, beauty, character, morality, etc., which cannot be measured quantitatively. In such cases, Carl Pearson's method cannot be applied. Here the new method applied is Spearman's to study correlation. So computation of Spearman's rank correlation coefficient. How to find out the coefficient of correlation by Spearman? He has given a formula. RS. R is the symbol for correlation coefficient always, and S stands for Spearman. To distinguish, if we write only R, it is assumed that it is Carl Pearson. When we write RS, it is implied that it is Spearman's correlation is applied. RS is equal to 1 minus 6 summation d square by n cube minus n. This is the formula to calculate correlation coefficient by Spearman method. So D is equal to difference between the ranks, and N stands for number of pairs of observations. Under this method, two types of problems will arise. First type of problem where ranks are given, and second type of problems where ranks are not given, we have to assign the ranks. If ranks are given, directly we can find out, directly we can easily calculate the Spearman's rank correlation. But sometimes ranks are not given, we have to assign the rank. So how to assign the rank? Take the highest value as the first rank. Highest value as the first rank. Then decreasing, we write the remaining ranks. Or the smallest value can be taken as first rank. Any way you can do. You can select either the highest as first rank or the lowest as first rank. But the same method must be implemented for both the variables. That point you have to remember. Then equal ranks. Sometimes we come across where equal ranks are there. So how to give equal rank? For example, two values are same. Now we cannot give third rank to one value, fourth rank to another value. We have to give the average rank. Two same values, if they occur, then we have to give third rank plus fourth rank divided by 2. That comes to 3.5. So we can give 3.5th rank and 3.5th rank. Like that, average ranks will be given if equal values are there. If the ranks are repeated, this formula of rank correlation coefficient will be modified. And written like this. RS is equal to 1 minus 6 summation d square plus 1 by 12 m cube minus m plus 1 by 12 m cube minus m plus 1 by 12 m cube minus m. Like that we goes on. It depends on how many groups we are having. For each group we have to add once 1 by 12 m cube minus 1. If two groups are there, 2 times we add. If 3 groups are there, 3 times we add the constant 1 by 12 m cube minus m. Where m stands for how many times the item is repeated in a group. In a group, how many times the item is repeated. That's all. So here just we'll get a bird's eye view regarding what the formula is. By doing practically problems, then the concept will be clear how to calculate the rank correlation coefficient and how to calculate the Carl Pearson's correlation coefficient. That's all. In examination, a theory question will be asked regarding what is rank correlation coefficient. So this theory, what I have explained now, that will be more than enough to write the theory question. And the formulas we will apply while doing the problems. So this video, I have completed the theoretical part of the chapter correlation analysis. I have explained you the meaning of correlation, what is the significance or importance of correlation, what are the different types of correlation, linear, non-linear, simple, multiple or total, partial or positive, negative correlation. All these things I have explained. Then methods, scatter diagram method, Carl Pearson method and Spearman's rank correlation. All these things I have explained in detail. Inshallah, in the next video, I am going to take up the problems on correlation analysis.